Okay, the next wave phenomenon we're going to discuss is interference. And the definition of interference is the interaction of two or more waves. And superposition kind of tells how they interact. When they interact, you simply add the amplitudes of the two waves. Okay, so our first example is we're going to have wave A is at a crest moving to the right. And then wave B is in the same medium. It's also at a crest, and it's moving to the left. When they get together, they will combine and make an extra big wave. And then afterwards, they actually pass right through each other as if nothing had ever happened. So we have B continuing on to the left and A continuing on to the right. Actually, interference is one of the proofs that something is a wave, because particles don't do this. This would be like taking two baseballs and throwing them at each other, and when they got together, the baseballs would get together and make one giant baseball, and then they would continue on their way afterwards. And that doesn't happen. Baseballs, when they hit each other, bounce off of each other. And now, when this happens, we've built a big wave, so it's called constructive interference. Because you're building up that big wave, and for sound, it would be loud at that moment when they got together. Now for light, big amplitude means it's bright, so it would be bright. Light. Now, I could also have this situation. I have wave A at a crest, and I could have wave B at a trough. And when they get together, they're going to wipe each other out. So momentarily, A plus B kind of disappear. And then, again, they continue on their way. They pass right through each other. And B would be continuing on this way, and A would be going this way. Again, going back to our baseball analogy, this would be as if the two baseballs approached each other. When they got together, they both disappeared, and then they appeared again and continued on the same way. Well, and building them up is called constructive interference. Wiping them out is called destructive interference. Second thing we're going to talk about is beats. We'll do a definition of beats. It is a pattern of loud and quiet sounds caused by the interference of two waves with different frequencies. I'm going to give a couple definitions up above here that I forgot that is going to help with this. When they're doing the same thing like this, they're both at a crest, or if they're both at a trough, this is called in phase. Or you can say they have a phase angle of 0 degrees. This is out of phase because they're doing the opposite. And that has a phase angle of 180 degrees. I'm going to use those definitions as I talk about this. Now, I have two waves here that have different frequencies. Because they have different frequencies, they're not going at the same rate. Sometimes they're going to line up. And like right here, you can see that these two crests line up. So what's going to happen at that point is I'm going to get constructive interference, and it's going to give me a big wave. So here we're going to say they're in phase. So it's constructive interference. And beats you usually see with sound, so we're going to say at that point it is loud. All right. Now over here, this one is at a trough, while this one's at a crest. So they're going to line up something like this. All right, so this one's down at a trough, that one's at a crest. So they are out of phase. And you can see the sum of them right here is giving me destructive interference, and it's wiped out. So what would happen with this, and then later on they'll be out of phase again, and then they'll be in phase again. So what you get is a quiet sound, and then it gets loud, and then it gets quiet, and then it gets loud. And I'm going to demonstrate that in class. I can't really do it on here because you won't be able to hear the sound. But I will show you this website, which illustrates at least them adding together. Okay, so here's an example of two waves. The red wave on top and the green wave have slightly different frequencies. So what's going to happen is sometimes they are going to be doing the same thing, and they're going to be in phase with each other, and that's going to be coming up right about now. Okay, this is at a crest, this is at a crest. They add together, and we get a really big wave. So for sound, this would be really loud. Okay, but then if I allow it to continue on, since they're out of phase, they're not going to stay together. Eventually, they're going to get out of phase with each other here, and this is at a crest, this is at a trough, and they're wiping each other out. So it would be quiet. So as time went on, it would get loud, then quiet, then loud, then quiet again. Now I can change the frequency of the beats by changing the frequency of the waves. So if I make them farther apart, okay, the frequency of the beats increases. Okay, so the beats come more quickly. So if I start it right here, they are out of phase. Okay, this is at a trough, this is near a crest, so they're going to wipe each other out. And then I don't have to wait very long until they're in phase again. Here they're both at trough, so I get a big trough, so it would be very loud. So now it's quiet, loud, quiet, loud a lot more frequently. So the beat frequency is a lot higher. So to find the beat frequency, you just take the difference of the two frequencies.